Yes, disassemble it like this. It's more convenient to work. Here it goes entirely with 3 rivets, and underneath it there are rivets for the holes. It needs to be very tight for the stuff.
Assembly fastener Cleco. It positions itself in the hole with its prongs and clamps simultaneously, preventing the parts from moving relative to each other. We have finished manufacturing the prototype of the airship's tail assembly.
We need the prototype to identify shortcomings in its strength characteristics and various assembly nuances.
We ended up with a riveted structure.
This is the first mock-up sample. We are sending it to experimental conditions. We will test its strength characteristics. After addressing some shortcomings and errors, our assembly will be refined and improved in manufacturing.
This is our payload. Its main task is to transmit its coordinates. For this, several systems are used, both radio and satellite. Our task is to investigate how it will perform and how it will adapt in the environment of reduced pressure in the corresponding stratosphere and at low temperatures, and the temperature that drops to -55.
This is a simulator of solar radiation in a near-infrared range, which will power the solar panels of the device inside the thermal vacuum chamber. We are installing it opposite the intended location of the solar panels. The power contact is brought out through a vacuum flange. Now everything is ready for testing. The tests being conducted today, which are part of a comprehensive evaluation process, are intended to confirm the accuracy and reliability of the readings of the payload barometer by comparing them against the precise and calibrated readings of the tested pressure sensor, as well as the operability of the payload equipment at different temperatures, including at extreme temperatures like -60 degrees. We have now placed the payload itself inside the thermal vacuum chamber with the solar radiation simulator. It is turned on, the antenna is extended into the radio transparent window, the thermal vacuum chamber is closed, and now we are ready for testing. Dennis will now check if we have a connection with the payload via the VHF channel. Once we confirm, the thermal vacuum chamber will begin its operation.
Well, 28,100. 48,200.
It should be 30. Yes, it shows 28.
There's already a 2-kilometer difference at 28. Oh, well, 1.8. 1.8.
Well, this error is already visible at this altitude. So, the error is always there, plus or minus 1 millimeter roughly, but it only affects the altitude here.
9,870. Well, the average was 9,880, and now it's 9,840, roughly, yes, 9,870. So, the temperature hasn't affected it yet. So now we'll just strip it down and freeze it without. Well, we'll make the worst case scenario. Being in its own casing, which is actually a thermal insulator, it did not react at all to the temperature drop to -30, meaning it was still around plus 25 to 30 inside. Or it would have taken, I don't know, 10 hours for everything to freeze to -50. That's why we separated it to speed up this process. And now we are using pure electronics in the worst conditions, in the worst case scenario, to freeze it to -50, and we'll see how it reacts. All right, close it. Let's try carefully connecting this lamp and this one, and this one. I'll connect the solar panels now, and securely. Because we took it out from the cold to room temperature, it got covered in frost, meaning condensation gradually formed on it, and thus, as a result, it continues to work. And telemetry is currently being transmitted, and the satellite beacon is working, so everything is perfectly fine. So, you can even see how its temperature is warming up now. You can see that the battery has warmed up. It's returning to its original capacity. Now it will warm up a bit. We are now checking if there is energy coming from the solar panels. Yes, here it is. It's giving 8 and 11 volts. That's it. It's not giving. This is how it gives. Our payload for this flight consists of a sophisticated module equipped with an advanced onboard computer system, which includes highly sensitive barometer sensors, precise temperature sensors, a state-of-the-art accelerometer, a reliable inclinometer, multiple voltmeters, comprehensive logging of all this data, plus a GPS system for accurate tracking. So, the main function is performed by this board. Next is the power supply unit. These are lithium titanate batteries, which can withstand very low temperatures, which we have just tested, along with a set of satellite beacons. All of this is powered by solar panels, which recharge the battery, and the power is supplied to the beacons and the onboard computer accordingly. After we also expose them to cold, the solar panels are still working, providing the specified voltage, so basically, everything is okay.